Hey everyone, welcome back. Those of you who were here yesterday, we are going to keep going with timeouts with Aoyuring and hooking those up to our actual event loop today. Something that's different from yesterday is I hooked up Zelaj to try to have a better layout than I had yesterday. We'll see how that goes, see if I like it. Still trying to figure it out. And you should also now see chat on the screen. I'm trying out Restream to do this both to Twitch and YouTube at the same time. Let's see how well that works. Alrighty. So, one of the things I like about Zelaj is I can get a pop-up terminal here, which will be nice for doing the compiling and running of everything. So just as a reminder where we were yesterday, we implemented the timeout. So you can see now that this is going to run for 3 seconds, then exit. Yep, so 3 seconds. Success. So next is hooking that up to the event loop, like I said. To do that, we will go to the idle loop. Split pane here to make sure that's not overlapping anything. Okay. And also go to our main file so we can see all we're doing here is timeout, loop.timeout 3, and giving it some continuations. The interesting thing here, so we have some continuations. Did we actually set them? No, we didn't. So let's see where continuations are actually used. Here. Okay. So and then when we enqueue, what do we do? Enqueue takes a continuation and appends it to our doubly linked list. So when we set a timeout, all we do here is enqueue this continuation. Okay. So the problem I see is that we need to create a new continuation just inside of this tick loop. So I guess it can just be right out here, which so we can say bar. Let's see, do we have a C anywhere in here? For continuation, don't see one. Huh. So bar C. Just say continuation is undefined. So this is just giving, oh, there is a C right there. So let's do this one, timeout, continuation. A little verbose, but oh well. So this is just setting aside the memory that we'll need for our new timeout continuation. And what we want to do is then just call timeout with self. Right now it only takes a second. We'll need to pass nanoseconds in here, but we can do that here in a second. Pun intended. And then we need a function. Let's just say it's 1 second for right now. Yeah, so we have to figure out what to do with this function. Callback here. I don't know yet. And basically we want to, like in our tick, just keep processing events until the timeout has been completed. And once the timeout is completed, then we can return. I think we want to do it at this level. We could drop down into the Linux version of this and do it just there, but I think we want to make this the same on any platform that it runs on. Just be agnostic to that. So what this tick thing is doing right now, let's get rid of these traces. We don't need them. Is looping through all of its continuations in the doubly linked list, which is here. That is, there we go. Okay. There's a overlapping keybinds there for ZellaJ. Control O is session, so I have to lock that. And Control O negative is like go back to the place you just were. So in we basically want like a nested while loop, which is kind of weird. So what would this look like? So let's just, what is timeout? It's just a void, right? It doesn't give us anything. And really we need it. So I'm wondering if we just skip the timeout thing and do this ourselves. Like this. That might make us a little bit more flexible. And we want that through for a second. Again, we need a callback still. Not sure if we need a callback here. I just might make this a dummy one. But I don't want to differ too much from how things are normally done. I mean, this callback could set a flag, and then we just keep looping until that flag is set, which might be the best way to do it. But the other thing I was thinking is this the timeout continuation has a status, and we could just check it not equals dot completed, which I think is a little bit better. So why don't we do that? So in IO loop, do we have where continuation is actually defined? I might want to. Okay, here. Let's do a. No, sorry. And, what's the word I want here for doing nothing? No op. We'll just do that. And we want it to be this signature. That. Like that. And then we just want to do this equals context, and this equals continuation. There. Okay, so now we have a no op. That's fine. That's all we really care about here. So this is just going to be a no op. That. So don't really like that name. I'm just gonna set this to timeout. For help if I spell it correctly too. Oh, of course, then it shadows. Fine, we're just going to call it T for now. I hate that, but let's see how that. Don't love that either, but it's something at least. And then we probably, for how long we want to do it, let's do it for like 10 nanoseconds, not nanoseconds, 10 milliseconds. I think that's what Tiger Beetle does in their version of this. Something like that at least. So we can do time dot nanoseconds per millisecond, sorry, times 10. And that should give us what we want. Still no flags on this. As I mentioned last time, we could set this to like an absolute instead of a relative, which might be a safer option. But that's a later problem we can figure out. Okay, so we have now a timeout set for 10 milliseconds. And we want to basically keep looping through our continuations and then doing an io.tick. So we can say, like right here, so while timeout c dot status does not equal dot completed, we want to do this. And I think that will give us what we want. And so every time we tick, we are basically running for 10 seconds and handling all the completions that are done and any that have been subsequently enqueued. We keep doing that until the timeout fires. So in theory, if we go back to our main function, we can see what's the best way to do this. We're probably just going to let's set this to something larger for a second. Zero. So basically I want to just set this to 1 still, just so it's easier to see in action. And then let's true that. We don't need that. And I think that's all we need. And then, so basically while not done, this is going to do a loop.tick. And I'm going to, let's see, debug.print. Let's see. I haven't ever just displayed a time or printed a time in Zig, so not sure what the best way to do that is. Let's just get the timestamp. What else can we get off that? Nothing. We're just gonna print the timestamp, see what that, oh, I'm doing this completely wrong. This. Let's do that and see what happens. All right, so if we do this, unlock, loading window, here, can't type it. Let's just make sure it builds. No, it doesn't. Okay, so we just need the pointer for this thing. Over here. So cool. We should just see every second it does something, but then it panics, which is not what we want. No address available. Okay, so I was worried about this because we're referencing things on the stack with this timeout. So I think we need to pass in the memory above, which is annoying, but we can do it. So I'm just going to set this as like a top level thing. So timeout. Defined, so just get some memory, and then on a actually it's not, just give it some memory. It should be able to just give it some memory, right? Let's just try it out and see what happens. So now this will have some actual space in the struct dedicated to it. So let's do self dot timeout continuation, which we want to get rid of this. Okay. I'm getting tired of typing continuation. Build it, run it. Cool. So then every 1 second it should keep going, but it's not doing that. So something is not working as expected. Okay. And this is good. So then it does, yeah, status is queued. Just do some debug printing here. Not my favorite thing in the world to do, but it's fine for now. I'll see if it's even getting in here or not. Yeah, so it's yeah, so basically it just hits that loop once. And never again. Or it does it one more time and then gets deadlocked. So why is that? I'm assuming we need to maybe clear out this. Let's just try it. Let's see what happens there. Oh, cool. No items available. Gene prediction. Okay, so it doesn't like that. So let's just pass it in from the outside. Which is, I mean, what we probably should have done from the beginning, but I was being lazy. Just checking the stream. All right, so continuing here, let's just try to figure this out. So I'm gonna make sure when this is here, we need to actually pass it in. Pass in a pointer. Maybe that was our problem. This needs to be a pointer. Let's see. Cool. So now we have that there. Get rid of this. And then when we do an IO init, we need to actually in here. think so. Doesn't like that. Probably. Then I no longer over here no longer need to grab the reference because it just is what it is. I'll just make sure this init takes a pointer as well. Yes, it does. Okay. Cool. That it does. Okay, same thing. So what are we doing wrong? So we're still getting the no address available. So I live 146 right here. That's odd. Oh, I think it's the data. I think. Crap. I think it's this that this is declared on the stack here, and then we're losing it. Maybe. Just take a pointer to the data. Well, it shouldn't. So there should be a copy of it. Okay, so let's just... this is not how I want it to look in the end, but let's just grab the whole, or create the whole continuation at the top level and pass that in. This here, and then don't need this here. This now moves over here. And this is C.NET. This is IO loop. So and then in here we're probably going to throw an error because we expect status to be queued. So we need at the end of this to not do this, but do dot status equals dot queued. I think that's what we want. Doesn't make sense. I'll need to refactor it in a bit, but I think that will give us what we want. Promising, except we're still now hanging. Yeah, we're still hanging there. Why would that be? Okay, so logically we are enqueuing this. We are waiting for the status to not equal complete. Oh, I think I know what I'm doing wrong here. Well, one of the things I'm doing wrong is in the Linux part, we want to in the tick, you'll see we are doing a submit and wait, and then a copy CQs. So we're doing these two separate things, but what we really want to do is both in one step, which I think is possible. dot. Oh, so yeah, we already do it. This self, or no, yeah, this submit and wait we already do right there. So we just need to move that up 1. And we are actually wanting to wait for 1 because we'll always have 1 done. And then this becomes completed that we have below. This, and then that's not right? I thought we need to copy out. If none are available, okay, so don't think we need that. So I think what we need here is dot ring dot so maybe we just do we need to copy into there, so I guess we still do that, and so we still want to just do like that. It was right before. It just needed to do the 1 submit and wait, so we're not busy looping. And then I think we can add back in our print statement here and just see what happens. Don't know if this will work, but let's try it out. Yeah. Okay, so that did what we wanted the first time, and it definitely waited for the 1 timeout, but now it's not actually, it's like it's not submitting the next one. So let's go look at that. I wonder if it has to do with what is handled complete to. Again, I want to get rid of the tracing, and then we remove the node and then decrease the count. So I mean that makes sense. Somewhere we're still busy waiting. Let's put it in here. Okay, so it's definitely in the inner loop that we're busy waiting. Okay, I have an idea. So we're getting stuck in here. We have I think we have like an infinite chain of nodes. Basically is the timeout pointing to itself somehow. Yeah, that's that. I have a feeling that that is what is happening. What is the best way to see that up? I just want to just drop one other. Yeah, so this, since this isn't printing a lot, so it has to be this. How can we overcome this? If I'm going to say n dot next. think this will work. It'll tell us if it is actually referencing itself. Make sure it builds. Yeah, it's self-referencing. Okay, so why is it not getting removed from the list of continuations? So do we have to self dot timeout continuation dot node, that's what we want, equals this. There we go. Because the node is the next thing in the list. I bet this will work. Nope, I was completely wrong. Okay, so why is this still not getting set correctly? So we're going to enqueue it, which is going to handle the queue. Right, so here's the tracing there. It's going to call that. Let's update the status to waiting. Get rid of the tracing. Retry isn't going to be triggered in this case. I'm not sure. Like, I don't really want to put this into Rose node. Like, if we go to this instead of wlinks.node, which we just want it to be null, right? So, what happens if we set this to null? I don't think you can. Let's see. Yeah, no, it has to just be instantiated. So that's how we do that. I wonder if in here, if we need to set the node that. And just do it here in the handle completed, so we are actually clearing it out. See if it likes that. No. So that didn't make a difference. All right, so in that case, probably just gonna have to step through this, which I have not done a ton of. In fact, I don't even remember the hotkeys for it. Debug. I want to. Yeah. Which. I want the UI. This is using DAP. Basically, I want to debug breakpoint, add a breakpoint here. Yeah. And then what else can I do with this? Okay. Widgets, profile. Okay. So I am going to say run with args. It's going to be that. And it's just going to be sorry, don't want to do that wrong. It's been a while since I've done this. Do that, no args, and we want this to be zig out, bin, venti. Okay, so now we are here. We can see some of the info. Okay. Locals, quotes, registers. Okay, so now we want to let's see. I want to put another breakpoint here. Theory. Yeah, so now we're stuck in this loop, right? So if we look at, I want to look at infos. I wonder if the debug info is broken in this version of Zig. Because normally you get your locals, like your local variables here. I don't really just want to deal with registers. Yeah, that's not going to tell me what I want to know easily. Okay, so that did not work. I'm using the a nightly build of Zig. Not nightly, just the latest version as of earlier today. So it's not surprising that things are broken on main. So this actually does not give us really what we want, unfortunately. Dang. Okay, so let's just get rid of that. Get rid of our breakpoints. So what does that leave us with? I mean, I think we want to actually just print the address here, which is, you Google that. Okay, it's just a star. So this is C. Let me do C.node. That. And then it's going to be just node. I would have to do if it has to do with this field parent pointer. I had not thought of that. So this is basically saying we have a node and it's the intrusively linked list, and this is getting the pointer out. So we want this just to be C and this to be node. I don't think this is going to give us exactly what we want. I want the C dot. No, in theory, like these have to be the same, so I mean that makes sense. Sorry, what I want is node and node.next. Obviously, we interesting here. While node here, but we don't actually use it. Node is in.next. What is n? Oh, duh, it's right there. So I mean, obviously this is gonna give us just what we already see, but I wanted to see it anyways. Yeah, so yeah, you can definitely see we have the same one here. Sorry. Oh. So you put caps lock on, you do stupid things. All right. So what happens, just, we have a C equals, just want to see what happens if we do that. I'm hoping everything blows up, but in an interesting way. Yep. So that's doing what we want. Yeah, it's waiting every second, doing exactly what we want. But that's because we've broken the list. No other reason than that. So do we actually want to set c.node to this before? Why isn't, like, why right here? Is that different than doing that in here? Configuration.node. I don't understand how that is different. So this C that we pass here is still that C right there. So I guess it's after we call in.next to it is the problem. Is it though? Yeah. So I think we're gonna have to do this a different way. So this fixes it, but this breaks everything else. So node equals in.next, which could be null, right? Yeah, it could be null. But since we're setting it here, we know in.next is the same thing. So this, going back up to this loop, will always have this. So I think we do just need to actually have a timeout callback. That knows how to break out of here. What if, I don't like this, but we just do a while true here, and then right here, if we do a if self.timeout status completed, we want to so break out of this block. Like that. And then we will, we won't set node into next. we'll just grab the first one again, and then I think we want to here do let's see, time of continuation. So we just want to then set here to self dot timeout continuation dot status equals dot queued. This is all very convoluted. I don't like this, but at least I want to get working first. So I'm basically just resetting this, which is, if we look at the main file, what this does, right? It just static queued and everything. I should say just this defaults to just being null. Okay. All right, progress. Unreachable. Cool. So we hit an assert in 58 of Linux. Gotcha. So we need to assert that this was waiting. Why is it not getting set to waiting now? Because it's now set to queued, but doesn't enqueue set it to waiting? We can see what it was. Waiting. Yeah, we can't. I have a feeling it's completed, and we still have a weird issue here. So the status is .queued. So why is it not? Where do we normally set that to .waiting? Let's go find that. Which I thought was in the enqueue. So this is on our loop enqueue. We do continuation.node. Okay, so that's all that does. So since we're breaking here, we're then setting it to queued. And then the next time we go around, let's go and look back up, see what it, so an outside while, an inner while. Okay, so we're not breaking out, like we're not getting the outside while again, which I would expect. So again, I don't really like debug or print debugging, but yeah, so it only hits tick once, then it hits the we're not even getting to the first initial print statement, right? So like we're never getting back up and hitting the time print that we had before. Now that we added this. What if I could do something stupid here? Yeah, there is a step debugger, but since I'm using like fresh build off a master, it looks like the debug info is broken. And it doesn't show me my local variables, which then doesn't help me at all. I'm gonna do something stupid here and do. Oh yeah, I guess it is LLVM based. So, that is a good call out because and that's probably why the master branch that's like the 15.0 dev version does not actually use LLVM. So that is probably why by default. So I could do, what is this? I forget what the flag is to make it use it again. Okay, so I mean I could just do release safe and we'd have it, but we still want more of like a debug build. Timeouts. I don't. Time to Google. Sig. I think this was in the devlog that they talked about this. Okay, so I see the F no LLVM, which will give us the opposite of what I want, but let's just try it. FLVM. Yeah, no, not what I wanted. Kind of annoying that this isn't just in there, so let's just do a build. SD minus equals release safe. And this will do LLVM. Cool, so I'm gonna set my breakpoints again. We still don't have. Oh, we do have our locals. Nice. Thank you for that. So we have. This is not available yet. Oh yeah, because we're there. So self.io loop. We have this timeout continuation with its status, which is queued. Should it be queued here? Yes, because we've hit enqueue. And init will set it to queued. Okay, so then if we, sorry, just jumping back around here. If we then, oh, and I realize now chat looks very weird. So let me move that down. Move that like up there. There we go. Cool. Then let's just run to the next breakpoint. Let's see. So node is what? So we still have the tag is timeout and the command. Previous and next are both null. callback is that. Status is still queued. Okay, let's get rid of that. And then I forget what these symbols mean. Of course, it's not going to tell me. So we want to let's see, step over, right? Yeah, step over is what we want. Okay, so right, because there shouldn't be a previous or a next, because we only have one item in the doubly linked list, right? So it should never actually, like, this should only ever go through the while node a single time. So let's look at this node. Previous and next is null. The n is a no, is a node. Previous next is null. That makes sense. What is C here? Is the parent. I would have thought that we'd have this here. Okay, now we do. So I guess this looks like it's off and it's one line too far, because now we do actually have that. So I think we're like right here in the actual execution. No, we executed this. So that's weird. I don't know why this variable was not there yet. So our C looks like this. Node, previous and next. I mean, that all lines up. The let's see, this the I want the commands not. Why don't I have the status? Oh, there's the status right there. It says, it still says it's queued, which makes sense because we need IO to tick. Oh, I'm dumb. Like without IO ticking, none of these ever change. So that makes a lot of sense. So I think this IO tick needs to come up inside of the while true loop. Duh. So, oh, it is in the while true loop, right? Yeah, it is in the while true loop. So that's not right. So we should get to this handled queued function here. Let me just go set a breakpoint in that. Oh, then, sorry. So this needs to come out of here because I had it here. I duplicated that code. So I think this is all just my fault. So let's just run through this a couple times. Yeah, I don't need this breakpoint anymore. Okay, so now we are in outside while again. All right, here's our infinite loop, I guess. Wonder if I can't do that. What if it looks like I need both these, which is annoying. Stop this. Definition of insanity, right? Keep doing the thing and expect a different result. I really do not understand. Okay, so let's look at the self timeout continuation. Its status is completed. So why are we still hitting this? Right? Yes, status completed. Oh, I think I know why, because you can do... I needed to put the block on this side. Right? No? That's not how it works. Alright, then I know nothing. Well, that's frustrating. So we're breaking to here. And like this should break. Something like this. Is it like that? Yeah, that's how it is. Okay, I was right that that's what it needed. I was breaking out to the wrong spot. Okay, so yeah, I'm still hitting here. What is... Why is it... Like, the timeout is completed, right? So the status is waiting. And then it's not... What? Oh, it says... I don't understand that. Oh, because I didn't save the file. Of course. How is this debug statement not just like not being hit? Oh, I'm so stupid. I haven't been rebuilding the binary this whole time. That is very frustrating. Yeah, let's just do that. There we go. Thank you. Let's try this again. And now I don't even know what state we're in. Alright, so our status is queued. Status is queued. Now our status is waiting. And now we've hit some kind of infinite loop. And everything is dying. Let's just get a new terminal here. Oh, yeah. So let's just see what happens. Okay, so we're still self-referencing somehow now. I'm constantly in the inner while. So let's see, where were we? I'm just going to do that so that we don't end up in an infinite loop. Cool, no worries, Dustin. Oh, now I need to move chat back down. That looks weird. Or resize it. Sorry, give me a second. Hopefully this doesn't just break everything. There. So hopefully that looks okay. And it looks like things have frozen. Of course. Maybe not. Oh no, it's like freaking out. try all the different things. Okay, I think we're so okay. Let me know if things broke. Just refresh the restream tab. Okay, so I think we're okay. Yeah, basically I just don't want to end up in that infinite loop again. So let's go ahead and get our watch going again. Okay, so now that is there. Let's do a breakpoint here, breakpoint here. And let's do a breakpoint here. Get our UI back. Okay. Now we're basically back to where we were before. We have our loop has a timeout continuation whose status is queued. Cool. So let's just see what happens. Okay, so we're here. Status is queued. Okay, status is there. And then it went all the way back up to there, which is what we expected. So then we enqueued the, so we saw the in tick as the last thing, and then we're here. So now we have our enqueued thing, and let's see what the status is here. So the status is queued here. The let's just see this. It's and it does have a previous and next set as I think that is undefined. Yeah, that looks like undefined to me, so that's just like garbage, maybe? Or no, it's self-referential. How did that happen? So I think in .next, how the heck did that happen? So when we do a handle complete, we remove it from the overall list. This is a new line, so let's get rid of that. That one, I'll rebuild here. I think this is the only place we set next. It's right there. So this, it has to be coming from there, I think. Let's see. From Apple project. Yeah, none of these other files matter here. So that's so weird. Okay, let's just try. Oh, stop this. Do this. Let's just step through this whole thing and watch. Our node should always have previous and next as null. Right, so over. Still null. Still null. Okay, so now we've compassed in node equals in dot next. And we still are null and null on previous and next. That still is correct. Let's jump over here. Handled queued. So let's just see what this does. This does queued. Data. Yeah, print timeout. So this is just submitting the SQE. Cool. So we have our first. Cool. Have my first ever ban. That's fun. There's some advertising. Let's see if now I can get rid of that from. Cool. So, got rid of that. That's good to know how to do, I suppose. Alrighty, so where were we? Okay, let's just jump back to where we were. Next and previous are still null. Okay. Now we're all the way back up to main and loop.tick. I'm just gonna run back to where we are because now we're back down into some internals. And somehow, as soon as we got back here, it is set to that. That is very weird. And you might see in the background soon, my wife is coming in to do Legos again. So that is what's happening there, if you notice. Yeah, I'm assuming Dustin is on YouTube because he doesn't do Twitch very much. At least that's what he told me. So how the heck did it go in here and somehow set? Unless we're just like referencing. I think we have a pointer to something on the stack, and that is messing us up. Yeah, so elevator pitch for a project is it's an event sourcing database from the ground up, so zero dependencies, basically, so I can learn every part of the stack as I go. The idea is it's kind of like Nats, but geared solely towards event sourcing. And so you can use normal like SQL queries like you are used to with Postgres to say, you know, get the most recent values of your aggregates and treat it kind of like a normal database, but still have the whole backing of all of the events that got you there. So let me just go to my README, and you can kind of see some of the goals. And like how it work is you would create an aggregate with like an ID and a name, and your aggregates can reference each other. So it has like foreign table keys or foreign IDs, and then all your events are strongly typed and defined like a schema in Postgres. And that way, if like it just rejects bad things, so you don't get bad data in. And then you can create streams, and from the streams you can listen to the events. Or if all you need is like the point in time most recent, you can just say like select something from the aggregate and grab it. I don't know if I have an example of that. I don't yet. Yeah, I don't have examples of queries. Yeah, so it's SQL compatible. And yeah, it's own DSL for searching. I don't know. It's more of just it's. There's a couple ways you can interact with it. So 1 second. You can just use plain SQL over Postgres wire protocol, so that no, it's fine. I'm trying to distract me because I'm kind of at a loss here, and I probably just need to revisit it at a different time to actually figure it out. So I'm fine talking about this. So yeah, so you can talk to it over Postgres wire protocol, which means you can just like use any like dbeaver or what have you, beekeeper, pgadmin, whatever, and then you'll get all your table schemas and stuff. And you can just write normal-ish SQL queries against it, and it'll just work. And then I'll also have a HTTP API for it, like that's kind of more similar to like what you see in like Nats or something, where you just say like get events, and you get like an array of events, or you can stream them. And then I'm also going to set up a WebSocket protocol so that, and I want to build that also like the PG wire, just from the ground up, so I understand that better. And then my idea, yeah, that's kind of the point. I see event sourcing as having this huge barrier, and you have these really great platforms that are built for streaming, but when you actually need to like aggregate the data and just get your current snapshot, it's super painful. So that's my target. And then the other thing I want to do is with Influx, we're always harping on performance and how you get the best performance, and getting no such thing as materialized views. Exactly. Let me just, I want to terminate that, so I don't want to think about that at the moment. So yeah, the whole point of this is to make it easy. Like a normal developer who knows how to write CRUD apps can still get all this power of event sourcing, but all they really need to know is select star from accounts, and they'll get all the current up-to-date things, and it'll just work. But I guess what I was trying to say, like, with what I've learned at Influx, that performance is key, especially on queries, and the best way to get the performance is to have the data available before you ask for it. So what I'm wanting this to be is kind of like SQLite, where you can embed it directly into your program, and it will you can specify exactly how much memory you want it to take, so you can make it very minimal, like how much cache, everything, and then what streams you're interested in. And that kind of connects, and that will connect to like your main actual database as like an edge node like Nats has, but you target it specifically for just what you're interested in. And then when you're asking it for data, you just talk to that local process, and if it has it, great, you get it right back, so it's like instant. And if it doesn't have it, then by all means it's just like doesn't exist. So the seeking process just happens in the background. So order to embed it inside of it, I'm going to be compiling it to WASM. So you could literally run it in whatever language you want, and including in the front end. So one of my targets is like in your browser, being able to connect your web client, and like say you have accounts, and you just in memory have, you know, your list of accounts or whatever that you want to display in your page, and you just basically proxy with that. Obviously that's very, very, very far away, but that's kind of my high level idea for it. And yeah, and you can see in the README, this is all open source. I need to make like a bang command in the chat to go to it, but these are all my like starting kind of goals for it. And the other kind of, I think, lesson that I've learned, I just realized I've been streaming without my light on this whole time. Let me do that. There. Now it's brighter in here. The other lesson we've learned a lot with Influx is query ooms. Like when you oom your database, like from a query, are extremely hard to track down. And that's one of my main selling points for Zig, right? Is every memory allocation is tracked up front. And kind of like Tiger Beetle, I want it to be, you know, you only allocate on startup and you never allocate again. So you will never run into out of memory errors. And you literally track every byte. Yeah, I haven't actually used DuckDB still. I know I've heard great things about it, and everyone seems to be using it. But yeah, it seems like that is a very common thing to do, and it's, you know, we did some event sourcing for part of the work at one point in Influx for like the management layer, and we ended up tearing it out, but it did end up being like you have this event, this, you know, stream of events, but really in your UI all you really care about is the last one. And so we did a bunch of weird wiring up and then state tracking like that, and it was painful, so we ripped it out. Electric SQL, I'll take note of that. I have not heard of that one. Postgres sync engine. And of course there's the oh, hey Joel. I'm just kind of giving a rundown of what this is while I struggle with a gnarly bug. So yeah, anyway, go read the README. It kind of gives an overview and some examples of kind of how I want it to look. And where we are in the project right now is literally still at the beginning. I'm at the point of like doing the IO and making a IO loop, and that's it, right? I have some parsing around like the startup message for Postgres. So, like, this is what it looks like. You know, major version, minor version, a user in a database, and a bunch of other things I'm not handling yet, like authentication, which obviously is super important. But this was fun to figure out, and this is kind of my learning too about how to try to make Zig as type safe as possible. So one thing that I found kind of fun is in some network code, I actually made a type for non-empty bytes, so that when you're using it, you can assume that, hey, you know, you have some set of bytes, which is, you know, I think a nice thing to have is something we have in Rust that we see all the time. You know, you can compare it to like the non-zero int types, which I also like. And we were talking about this some yesterday too, but you guarantee that through asserts like everywhere, because since it's Zig and super low level language, anyone at any point in your program can reach into your struct and change things. So you have to kind of guard against that. But as long as you have these asserts and things, you know, aren't panicking, you can be confident that you don't have an empty set of bytes. It's like when you, this was also kind of fun code to write, and this was before I did the IO loops. So all the tests are, you know, just using pure data. So like if we run down to the types. And here, another thing is, you have to solve like what a network int is. So over the network, integers are encoded in big Indian, and then in native, there'll either be little Indian or big Indian. So you have to take that into account. So I made literally a new type, right, called network int, and this shows again some of the power of Zig's like comp time. So you can basically get like a network int of any size, and be able to be sure that it's big Indian, and then you can say to native and understand what it is. So like here you can see I grab like a U16 network int out of this hex 1234, and then like that's the network version in native, and then you expect going back and forth between the two, they equal. And you can do serial. So say you have a long like string of bytes, like you're trying to decode off the wire. So you can say init your buffer of non-empty bytes, and then I'm gonna write a U16, a U8, a U8, and a U64, like, and that just writes into your this buffer that we have here. And because of the network int types that we built up, you end up with just a big string of bytes, but then you can go back and forth between them. And then the opposite is true as well. So you can deserialize, and then you can grab the next int, or you write the next int. And then writing can fail. You have to handle that. And then doing the same thing with strings as well. It's not just ints. So you have a big buffer of bytes. I made a write string, and then a deserializer, which pulls the next string off the wire, and it is null terminated strings is how I implemented them. So you can see that. Let's see. Yeah, I mean, this is just basic like handling of bytes and looking for the null terminator. So you can see right here, like if char equals 0, that's your null terminator. So you found a or your sentinel, I guess is what I called it here. So that's how you found your string, and then you return it. So like if we go back to startup deserialization, so pulling things off the wire, we pull the length. Like first thing it sends us is the length, which is U32, and we keep track of how much we've read the whole time. And then after the U32 is the major version, the minor version, which is these are both U16s, and then you have maybe a user, maybe a database passed into you, and then you want to and any number of params as well. So that's where this kind of gets hard. All your kind of like query params on your Postgres connection string gets transferred into the startup message, and this is just pulling those off. You have a key and a value, and just double checking all those, and this being able to call just like next string makes it super easy. So like if we go down to, and then the same opposite obviously for serializing it, you keep track of the size so you know how much you've written. And so like say you have a startup message, which is the only version right now that's I support is the latest version, which is of the protocol of the Postgres wire protocol, which is 3.0, and Bob, and then no password, or no database. Sorry, I haven't done passwords yet. Wait, is DJ commenting in both places? Very nice. Appreciate it. Appreciate the views. Yeah, so it just goes both ways. And another fun thing about Zig is they have at least a basic fuzzing implementation in the language, and Andrew Kelly, the creator, really wants to make it one of the like big selling points. So like what I'm doing here is literally just like throwing random bytes at the serialization, deserialization, and making sure it works, and it does. So it handles like it never panics on. At least I haven't found any panics yet, or just throwing junk at it, which is fun. Alright, so back to where we were, because I'm probably going to end the stream here in about 15 minutes. And I don't think I'm going to fix this issue today. Just probably need a break for my brain to understand what's going on. So we have some memory set aside. I wonder if I should make this not a pointer. So we have a I want that to not be a pointer. Okay, it's just on the. It should just be on the IO loop struct. Like the caller shouldn't need to know that. Like at most we'd make them pass in a timeout, but I really don't think we should make them pass that in like here. So I want to just grab this, maybe put it here. I think the problem is the data field of this is probably the problem. I could be wrong, but seems like it is to me. I could be wrong too. I want to go back to doing that. Need to fix here, get rid of that. That's fine. Do we still have our... Yeah. Let's get rid of this. See what happens here. Cool. So this is 50. Yeah. Self.enqueue. This should never be changing location, and we should never have to worry about it not being there. Okay, so yeah, so we but still hitting a self-reference. Want to see in Zig in the debug build or debug mode, they set like if you have undefined data to a specific value, and I want to see what that is just to make sure that this isn't undefined. It's okay, so it's not. So in debug build, undefines are 0 1 0 1 0 1, just repeating. So this is definitely not undefined. So we are definitely, we don't have an issue with the stack, I don't think. we are just self-referentiating ourselves into non-existence. Let's just go back to some basics here. So I'm just going to get rid of some things and get us back to where we were before. I think I just want to return here. I don't think I want to break. Okay, so we enqueue our timeout continuation, which is going to be set when we are initializing. So we init it. And then so we are in our while node loop here. And at the start of it, if we've blown up, we just want to return. If else, we want to do that. I think just right here too, let's do a continuation node. Let's do this logic here. This is a bad way to do it, but I'll clean, like I said, I'll clean all this up after I have it working. Okay, so now we loop through all the nodes, and then we call io.tick. But if our continuous status is completed, then we note that we're done and not to do anything else. But still, somehow it gets set to be a self-referencing. I really don't understand how that's happening. Long shot here. No. That's not it either. Is it? Like, this should already be happening, but just want to make sure. Like, we should never. Like, right here. Like, that should never happen. Obviously, it is happening, which is the problem. Oh, man, we need the pointer here. Maybe that's the problem. Are you kidding me? Now it works. So So what was it that actually did it? I think it was the remove. Yep. Okay. So why? So this should just be a it's not equal that. So that is now an assert because I don't want to catch that ever again. But in handle complete, it should be removing here. So why is it not doing it? Oh, I know why it's doing it. Wow. Okay. So the whole problem here is that when we first run through this, we're going to add the continuation for the timeout, and then we're immediately going to go through all this. It'll still just be queued or waiting because it hasn't been completed yet, and we're going to hit here. It's still nothing's going to happen. We're going to get back up to here. It's going to add it again any X number of times, and then we will be SOL. So we need to do something differently. So we need to only enqueue this if it's not already queued, which is annoying. So let's say if self dot motion dot status let's see, not equal dot waiting, and then we do this. So if it's waiting, we don't want to add another one. So if it is, the status is queued or completed, then we do want to add it. It's only when it's inside IO urine that we want to not do it. That's my take on it. Let's see if that works. I have my doubts. Yeah, okay. What? We should assert continuous equals queued. Yeah, so it's not getting reset to queued, which makes sense. So I think right in here we want to do this. I don't like how convoluted this is getting, and I want to refactor all this, but I just, want to watch it run. Nope, still didn't like that. Assert node. Okay, so that works. So it's adding one when it shouldn't be. Yeah, in theory. Yeah, I think we just need to use the actual callback here to make it work better and set itself back to queued. versus whatever is happening. So like this will be, because this one can be in completed, like this could be in the completed state before it's handled completed here. So it really needs to be updated by its, even then. Yeah, I think something fundamental needs to be changed here. And yeah, so yeah, Joel and everyone else and Dustin and did great on that Rust rewrite. I would never do it again, but they did great on it. And I think everyone's happier now writing Rust than Go. Yeah. Joel's still our Elixir expert. He handles all things Elixir. It doesn't work. Okay. Alright, this is broken, but it's fine for now. It waits a second, and it's ugly as all get out, but I'll fix that later. Alright, well, I think I'm going to call it there for tonight. I need to think about how to refactor this because it's definitely ugly at the moment. Yes, I haven't actually tried Ash, but I've heard from DJ that it's amazing, so he can sell you on it. Alright, well, thank you all for coming and hanging out. I'll be here again tomorrow evening at the same time. So I will